Completing the square revolves around two different ideas. The first idea is the pattern of perfect square trinomials. So remember, all the trinomials we're talking about in this case are like y equals a x squared plus bx plus c. Perfect square trinomials follow a very specific pattern. They result when we're multiplying two binomials that are the exact same by each other. So for instance, a plus b times a plus b results in the pattern of a squared plus 2ab plus b squared. Completing the square is about taking trinomials that are not perfect square trinomials and turning them into perfect square trinomials so that they're easier to factor. Let me show you an example. Okay, here we have a trinomial x squared plus 4x plus 3 equals 0. This is not a perfect square trinomial. Notice 3 is not a perfect square, and the factors of 3, because it's not a perfect square, couldn't then add to 4. So what we want to do to make this perfect square is we want to turn this into the perfect square that would have 4x as its middle term. Notice we have the 4x as our middle term here. So the first thing we do is we simply add or subtract 3x from both sides, or subtract 3 from both sides. So we have x squared plus 4x equals negative 3. Now we want to think, okay, what perfect square trinomial is going to have this 4x as its middle term? And the way we can determine that is 4 is the coefficient, divide that by 2, that gives us 2. 2 squared is 4. So we end up adding 4 to both sides. Plus 4, plus 4. Thus we have x squared plus 4x plus 4 equals 1. Now this is a perfect square trinomial, and we can factor it as such. It's the square root of this is x plus 2. Okay. Then we also, if we take the square root of the one side, we have to take the square root of the other side. So what's the square root of 1? The square root of 1 is just 1. So now we have x squared, x plus 2 equals 1. We have to solve for x. This is just a simple one-step equation. Subtract 2 from both sides, and we get x equals negative 1. The other square root of 1, though, is negative 1. So we have to deal with that, too, just like we did with the other problems. In this case, when we subtract 2 from both sides, we get x equals negative 3. So the solutions to this trinomial are negative 1 and negative 3. And that's completing the square. Let's try another example quickly. In this next example, x squared plus 6x plus 5 equals 0. Once again, we have a trinomial, but it's not a perfect square trinomial. And we know that because, once again, 5 is not a perfect square. So it wouldn't work out to be a perfect square trinomial. But we want to turn it into a perfect square using our completing the square method. So what we have to think, first we subtract 5 from both sides. We end up with x squared plus 6x equals negative 5. Then we have to think to ourselves, okay, x squared plus 6x might be part of a perfect square trinomial. What part? Well, we always follow the same pattern. We take this b coefficient, we divide by 2, and we square it, just like we did in the last one. In this case, b is 6. So 6 divided by 2 is 3. 3 squared is 9. So we're going to add 9 to both sides. So plus 9, plus 9. Therefore, x squared plus 6x plus 9 equals 4. Now we take the square root of both sides. Because it is a perfect square trinomial, we can take the square root of both sides. And therefore we get x plus 3 equals 2 and negative 2. So both positive and negative 2. And then we have to solve for both of those. X plus 3 equals 2. Minus 3 x equals negative 1, x plus 3 equals negative 2, minus 3, x equals negative 5. So our solutions are x equals negative 1 and negative 5. And that's completing the square. It's taking some trinomial and turning it into a perfect square trinomial. And just try to keep track of which ones are perfect square trinomials. We know x squared plus 6x plus 9. We know x squared plus 4x plus 4. X squared plus 2x plus 1. All of these are perfect square trinomials. So those are the kind of trinomials you're looking for.